Here we're going to solve this system of equations. There are three variables, x, y, and z, along with three equations. So it looks like I could use the elimination or substitution to get started. If I did substitution, I could easily solve for this x and then plug that expression into these two x's. Or it looks like my y's are set up really nicely for elimination, negative 2y, and then these two equations have plus 2y's. So it looks like I could add up my first two equations, negative 2y and positive 2y, so my y's would cancel. And then I could add up my first and last equations, and again the negative 2y and the positive 2y will cancel. So first, let's go ahead and add up the first two equations. Negative 2x and 5x makes 3x. My y's cancel, and 4z and 2z makes 6z, and then that's going to equal negative 13. So similarly, I can also add the first and last equations together, and that will also produce a new equation that does not have a y. So negative 2x and a positive x makes a negative x. My y's again cancel, so 4z minus 6z is negative 2z, and that'll equal a negative 14. So now I have a new kind of a subsystem here with two equations and two unknowns. So it looks like I could use elimination pretty easily, and I could eliminate my x's by running a 3 through this bottom equation. So let's go ahead and rewrite the first equation. It is unchanged. And now let's go ahead and run this 3 through the bottom equation. I'm going to multiply every single term, including this constant over here, by 3. So negative 3x, negative 6z, and negative 42. So the point of that was to eliminate my x's, but it looks like it also eliminated my z's. So my left side ends up being just 0, and my right side ends up being a negative 55. Well, I'm out of variables. All my variables canceled, and I was left with this false statement, 0 equals negative 55. So I know that this system has no solution.